This is 2.8b as in boy, continuing on with addition and subtraction with mixed numbers. We're in example 4, and we're adding 3 mixed numbers this time. So we're finding common denominators for the numbers 4, 5, and 10. So I'm going to go ahead and break those down. So 2 times 5, and this will be just a 5, and this will be 2 times 2. So my 2's occur the most there. Get rid of that. 5 occurs once there. It also occurs once here, but you just pick one and cross it out. Multiply what I've got circled, and in this case I have 20, so I know that 4, 5, and 10 all go into 20 evenly. So let's go ahead and see what we can come up with here. So I'm going to bring my 3 here. And what did I have to multiply? 4 to get 20. I had to multiply it by 5. So 5 times 1 is 5. I've got a 2, and common denominator is 20. What did I have to multiply 5 by to get 20? That would be 4. So I multiply that by 4. And I've got a 20 here. Put my 1 there. I multiplied this by 2 to get 20. Multiplied my 9 by 2. Alright, now I get there. I add up my top numbers. 5 and 12 is 17, plus 18 is 35, and 3 and 2 and 1 is 6. And there's my answer, except this is improper, so I need to change that. And 35 over 20. 20 goes into 35 once, with 15 left over. So I add those up and I get 7 and 15 20ths. Now what you'll notice here is 15 over 20 is not reduced because you can pull out a 5 from both the 15 and the 20. So if we pulled a 5 out of 15, 15 divided by 5 is 3, 20 divided by 5 is 4. That's the reduced version. And I knew that right away by looking at that because one number ends in 5, 15, and one number ends in 0, which is the 20, and I know that 5 always goes into numbers that end in 5 or end in 0. So I knew right away that I could reduce that by dividing both the top number 15 by 5 and the 20 by 5. So that's called factoring out a 5. And that always means division, divide by 5. It does not mean subtract by 5. You don't get 10 over 15. You divide by 5. That's factoring it out. And that gives us 7 3/4. So when we do subtraction, it's going to be the exact same as addition, only we're going to subtract instead of add. But let's jump to example 7 here, just because we're talking about a whole number and a fraction. And we're going to subtract those. So we're going to do something a little bit weird with this 10, because if this is a mixed number, then this also has to be a mixed number. So we're going to change that 10 to a mixed number. So we're going to write 10 as 1 less than 10, and then we're going to write it as 7 over 7, because 7 over 7 is 1, 1 plus 9 is 10. Now why did I pick 7 over 7? Well, that was the denominator here. So that means it's already given us common denominators. I could use 6 over 6, 8 over 8, 222 over 222. Any number over itself is 1, plus the 9 gives me my 10 back. So lower at 1, look and see what the denominator is here, and make the top and bottom the same number, and this is the same as 10. So now I can subtract 5 and 2 7. So 7 minus 2 is 5 over 7. 9 minus 5 is 4, and you're done. So this is example 8, and it also is a little bit tricky. Now let's look and see what makes it tricky. We have common denominators, so that's good. We don't have to do any of that. But our problem is, in addition, when we have common denominators, we took 1, added 3, and got 4. Well, this says we take 1 minus 3. Well, we can't do that. This number has to be bigger than this number when we subtract. So we have to do kind of like what we did in the last example. We're going to change that 8 to a 7. And remember what we did is we put this common denominator on the top and bottom. So at this point, what we have there is 8 is the same as 7 and 4/4, and we also have a 1/4. Remember, that's just the same. A mixed number is the same as taking the whole number and adding the fraction to it. So that's what I did. I took the whole number and added the fraction. So that equals 7 and 5/4 now. Okay, so I kind of went backwards. Remember, when you have an improper fraction or a mixed number, you cannot have an improper fraction as part of it. And we do here, but we're not. That's not our answer. We're just using it to get to where we want to go. I'm sorry, this is supposed to be a 4, isn't it? So 7 and 5/4 is the same as 8 1/4. Now let's go ahead and put this 3 and 3/4 back. And now we can subtract because this number is now bigger than this. This is just another way of writing 8 and 1/4 so that we can do our subtraction. So 5 minus 3 is 2, 7 minus 3 is 4, 2 over 4 will reduce to 4 and 1/2 because 2 goes into 2 once, 2 goes into 4 twice, and that's where we get our 4 1/2. Alright, so the next example, which is example 9, will be probably the hardest that you'll ever run into when it comes to subtraction. So it's good that we're going to do that for an example here. Now I say it's the hardest example, it just has a whole bunch of the stuff that we've already done mixed together in one problem. So first thing we're going to do is find common denominators. And in this case, our common denominator is 12. And we multiplied that by 3, so we have to multiply that by 3. And 1, and this is a 12. We multiplied the 6 by 2 to get it to be a 12, so we have to multiply 5 times 2 to get that to be a 12, or a 10. And this is our new problem. Okay, so the next situation that we run into is 9 minus 10. We can't do that. This number has to be bigger than this number. So that brings us to our next step, and we have to make this number bigger than this. So if you remember in the last problem, what we did is we borrowed from the 4, so we made that into a 3. Remember doing that? And that was 12 over 12. So that equals 4. Then we have our 9 over 12, which is right here. We just rewrote it. And I'm going to leave this one alone, 1 and 10/12. That doesn't have to change. It never changes. And let's go ahead and write that then as 3 and 21 over 12. So I added my fractions together there. And then I have 1 and 10/12. Now I'm going to subtract. 21 minus 10 is 11. And 3 minus 1 is 2. So I have 2 and 11/12 for my answer.